Hello everyone and welcome back to the C Cubed channel. Today we're going to be continuing on with quadratics, and we're going to be looking at solving simple quadratic equations. So this is going to be kind of branching off from the last two videos where we had to expand, most actually is more of the last video really, but you get the idea. So this is a tier 1 video. This is for those doing GCSE foundation maths with the Edexcel exam board, and it's also for those who wish to be starting from the basics. So, as I said, this is kind of branching off from the last video where we were looking at factorization. That's mostly what was going to be needed for this video, as well as kind of remembering how to solve linear equations, and that's something we've done several videos ago now. So if you're not familiar with those, I'd recommend to go back and look around that. I would recommend to refresh yourselves on that because that is going to be useful for this video. So, we're going to do a very quick recap on solving linear equations. Got to remember how to solve equations. That is the linear ones, which is just a simple x, just x in each case. So let's just quickly go over these very fast, just to remind ourselves. So x plus 3 equals 9. Okay. Now remember, what we've done with solving the linear equations is we keep saying we need to isolate the x. We need to get x on its own, and the way to do that is we manipulate the other terms. So if we want to get x on its own on the left side here, you have to subtract 3 from both sides, because in this case we're doing x plus 3 minus 3 is equal to 9 minus 3. And on the left side there, plus 3 minus 3 is equal to 0. That cancels out completely. So we're left with x equals 9 minus 3, which is 6. And just like that, x is equal to 6. Okay. So for the second one, remember again, isolating x, and we're going to do a similar procedure. We're going to get that x on its own by moving the other terms around. So in this case, we're going to do 4x, and we need to get a 4 to the other side, so we're going to subtract 4 from both sides to get the left side to have no 4, basically. So we're going to have 4x is equal to minus 4. Oh my god. There we go. So minus 4, we move the 4 over to the other end, and just flip the sign basically, but you can see it as that as well actually, because that's valid too. So 4x equal to minus 4. And now if we want to get rid of this 4 here in front of the x, we just divide both situations by 4. So just divide both by 4. So you've got the 4's will cancel on both ends, so we're left with x is equal to minus 1. And that's what we're left with. X is equal to minus 1, done. For the last situation here, we need to get rid of this fraction. So what we do is just multiply the 2 over to the other end. So we have x plus 1 is equal to 3 times 2, which is 6. And then we just move the 1 over to the other end by subtracting 1 from both sides. And we're left with 5. And done. That's it. So that's what we've done with, solving linear equations, that kind of thing. So that's the standard procedures done with that. And we've already covered this several times now. We've done it with linear inequalities. We've done it with, the actual original sessions. So at this point, I would expect that you have some practice with this. I would expect that, you would be quite comfortable with doing these kind of things, because this is a very essential skill to have, especially when we look into the other topics such as geometry and statistics, algebra, calculus, and all that. Well, calculus is in A level, but still, it's all very, very essential basic knowledge that will help with everything. So much like with quadratics actually. So we're going to be talking about that in a sec, but yeah, so this is good to remember. Always good to remind yourself over. Keep going back over it, and you will get better. You will get better. So, yeah. Alright, so now we're going to quickly recap over expanding and factorizing quadratics. So in the last 2 videos we were talking about both of these things. 2 videos ago it was expanding quadratics, the last one was factorizing quadratics, and obviously this session will be solving them, or solving the easy quadratic equations. So, but to do that, we need to kind of get down with this. We need to kind of remember and familiarize ourselves with this kind of thing. So, for the first bit, remember we said when we expanded quadratics, you just quite simply multiply them all individually. So we're gonna have x times x, which is x squared, and then x times 4, which is 4x. Sorry. Alright, and then we have 2 times x, which is plus 2x. And then 2 times 4, which is 8. Oh god, that's an awful 8. Alright. And then we just quite simply simplify that middle bit there. So we're left with x squared plus 6x. Oh. God, I cannot draw. Oh, right, rather. And then we got plus 8 at the end. Simple as that, done. Okay, so that's all there is for expanding. That's the same procedure you do for everything. So nothing really new there. For the right side, remember with factorizing, the general premise is that we need to look for 2 numbers that add to the middle term and 2 numbers that multiply to give you the last term. So let's just quickly write that out. Now again, as I've said in the last video, it's never really clear what the numbers will be in some cases, so you might have to kind of do some trial and error here. You might have to guess around a bit, play around with combinations to get the right ones, but eventually you'll get there. That is with equations like this. So what we do here, we multiply out well, actually we need to find 2 numbers that add to 9, 2 numbers that multiply 14. Now I've already done this before the video, so the answer here is 7 and 2. So remember, 7 plus 2 is 9, and 7 times 2 is 14. So the end result here would be x plus 7, x plus 2. Alright, and that's all there is for factorizing. So this is all the stuff we've done in the previous videos, but it's good to go over this right now, just so you can refresh yourself and remember, because this is going to be essential for what's coming up in this video. So now we can actually get on with the actual content itself. So now we're going to be talking about quadratic equations. So in contrary to linear equations, we found that we always got one term at the end of these. You know, we always got one solution, because x is equal to something and that's it. Now in this situation, we are going to find that a quadratic equation has 2 solutions. So there's always 2 answers to a quadratic. Now, yeah, sometimes there are a bit of weird cases where it might look like you have one, but in reality, there are always 2 solutions. And every quadratic equation has 2 solutions. Like every single quadratic equation imaginable has 2 solutions. Even if it might not be, it might not be apparent for GCSE. There might be some equations where you can say they don't have any solutions, but they actually do. But that's for a different thing that's coming up in the future. But we're not going to touch on that now. We're just going to talk about the very basics here. This is the simplest kind of equations you can get for quadratics. Now, I should also add, this is kind of the bridging point between foundation algebra and higher tier algebra for GCSE. So after this video, we're going to be going into tier 2, which is looking at those doing the higher tier. So this is about the hardest you'll get for foundation algebra. So this is kind of the end point for foundation. Okay, so we said quadratic equation is an equation with 2 solutions, and so we can see they follow these kind of formats here. These 2 are usually the more common ones you'd find for foundation. So it's either in a factorized form like this, where it's equal to 0, or you have just the polynomial form, which is equal to 0. Now I said down here that you always equate it to 0 when you're doing equations. Quadratic equations and upwards, so you would have cubic, which is x cubed, and then quartic, which is x to the power 4, such you just, anything from x squared and above, when you're solving them, you always set it equal to 0. And we'll see why when talking about just quadratics, but it will apply to all the others as well, especially with the first one here. So, let us take a look, and let's mess around with the factorized form first. So, the goal with quadratic equations when they're equal to 0 like this is we need to find two terms where the entire thing will be equal to 0, right? So you need to find two values of x that will make the entire thing equal to 0. And this is the reason why we make it equal to 0, is to find what x actually is in the first place, by the way. So that's the main reason, because otherwise we would not be able to find what x is in this case. So what do we do? Okay, so let's take a look at the brackets carefully. We have x plus 1 and x plus 2. Now, they're both multiplied together. So the thing is, we have to make one of them, we have to make x equal to, something where one of these two will be equal to 0. And that will make the entire thing equal to 0. So that it will be equal to the right side. Now, that might sound a little confusing, but we're going to go over this slowly. So, let's take a look at x plus 1 here, right? We want to make this here equal to 0, right? So let's say x plus 1 equal to 0. Okay? So, now this is a linear equation, so we already know how to solve these, so we just move the 1 over to the other end. X is equal to minus 1. Okay. Now if you put minus 1 back into this, you'd find minus 1 plus 1. By the way, when you find x minus 1, you don't put in just this one, you put in this one as well. So you'd have minus 1 plus 2. Now, it doesn't matter, but this term here doesn't actually matter, because you can see on the left side here, minus 1 plus 1 is equal to 0. And 0 times this is also equal to 0, which in turn satisfies the right side, because that is also equal to 0. So, we basically just found a way such that the left side is equal to the right side by making x equal to minus 1. So this here, this is one of the two solutions for the quadratic equation. Alright, now to find the other one, you've probably might have guessed it by now, you have to make this equal to minus 2. Because x plus 2 equal to 0, you gotta solve that, and you get x equal to minus 2. So let's just quickly go over that very slowly here. So we got x plus 2 is equal to 0. Alright, try to make this bracket here equal to 0 now. So we move the 2 over and you get x equal to minus 2. And like with this down here, if you put minus 2 in both of these, you'd find this term now will equal to 0. And 0 times that is 0, which will give you equal to 0 at the end. So there we go. So therefore, the solution to this equation is x is equal to minus 1 minus 2. So it's equal to minus 1 or minus 2. That's the solution for this quadratic equation. And we've just solved it there. So that is the general premise with solving quadratic equations, actually. That is kind of the goal. This is the step you want to get to. That is, this is one of the many ways of solving them, but this is the simplest way. This is like the easiest one, which is covered for foundation tier. So that's what I'm sticking with. So this is literally the solution. That's what you get. So with the other one down here, we can kind of see a similar thing. So I'll start with the right side here, x plus 5. So again, we are literally doing this. Now the procedure is exactly the same as these here, so I'm not going to write it again. But if you want to do it yourself and practice, you may. I'm just going to jump straight ahead because it's kind of self-explanatory at this point, I think. So in this situation, the answer here to get everything equal to 0, x has to be equal to minus 5, and that's because minus 5 plus 5 is equal to 0, and that will make the entire thing 0, which is equal to 0. You know, it sounds a bit crazy, but that's that's how it works. So in this case, x is equal to minus 5. Now what about this one here? X minus 4. Okay, so this one we're going to quickly just do the same method here. Alright, x minus 4 is equal to 0. We'll make the, remember we have to make the entire bracket equal to 4. Now, to solve this again, we just bring the 4 to the other end, but now we have a positive. X is equal to 4. And this works because you can clearly see, if you put the 4 back in here, 4 minus 4 is 0. Right? So, yeah, 4 minus 4 is 0, and then that will make the entire thing equal to 0. And that will equal the right side. So, that works as well. So remember, basically, I mean, the simplest way to see it with this kind of form is the solutions are quite literally just the opposite sign of the number, in a way. So for example, we have x plus 1 here, so the solution would be x equal to minus 1, and then x plus 2, so x would be equal to minus 2. Same here, x plus 5, so x is equal to minus 5, and x minus 4, so x is equal to 4. That's the that's kind of the way to think about it. That's like a kind of trick, kind of fast way, and it is valid because of this procedure we've done here by doing them individually like that. So for this equation, we say x is equal to 4 and minus, or 4 or minus 5, and that is it. So that's with solving quadratic equations where you already have it all factorized out like this in factorized form. Now this is a more, this type here is the more common kind of quadratic you'd find. Now, I would say from my personal experience, this is, quadratic equations are, in this form at least, are probably the most, well, one of the most common equations you will face ever in the fields of maths and physics. Especially in physics, you'd find quadratics everywhere. Even in places you would never expect it, they just show up everywhere, like literally everywhere. Even in maths as well, actually, the quadratics just appear at, just randomly. But they appear very often. So it is. So I mean, if you want to progress on to the higher tier stuff, and eventually, if you're going to be going into A levels, if you're going to do A level maths, for example, then mastering this is essential because quadratics are going to appear everywhere. You're never going to see the end of quadratics. I'm telling you this now from my personal experience of doing all that. So just take that, for what you will. So now let's go ahead and take a look at this kind of equation. So this is the more common quadratic equation. This is the one you find the most. So x squared plus 4x plus 4 equals 0. Now, what we want to do here is we want to get it such that we need to find the two values of x here. And we need to do it through getting it into this form. Now, you can probably see where this is going already. Yes, that's right. We are going to be factorizing this expression here. Well, we're refactorizing the equation. So, let us begin with this. Now, for the record, just to say, this is one of the many ways of solving equations, but this is the simplest way. There are many different ways of solving them, as we will learn coming up in the next few videos. We'll be learning about different ways to solve equations, but this is the simplest one. This is one of many, but this is the easiest one, I'd say. Okay, so now we're going to be factorizing out this equation here, x squared plus 4x plus 4. So we need to factorize this out. So how we do this, remember, we need to find two values that add to 4 and two values that multiply to give you 4. Now straight away you could probably think, okay, it's probably 2 and 2, and you would be right. Because 2 plus 2 is 4, and 2 times 2 is 4. So in both situations we have x plus 2 and x plus 2. Okay, cool. Now we can see x plus 2 appears in both situations, right? So, yeah, so x plus 2 appears in both situations. So we could just solve for, I guess, one of them, and you'd find both of them will be valid. So, remember as we've done before, x plus 2 is equal to 0, because we want to make one of the brackets equal to 0, and then just move it around. Yeah, x is equal to minus 2. And now minus 2 goes into both brackets here. So now we're left with, x equal to minus 2 as the solution for this equation. Now, the thing to say here is that in this situation there is basically one, well, there are technically two solutions here, but because if you do the other bracket you would get exactly the same answer, so you could just quite simply leave it as x equal to minus 2. And you can say that you just get one solution out of this. I said earlier in this video that quadratic equations always have two solutions, and this is the case here because both the brackets would give you minus 2 individually, so technically there are two minus 2's, but for the sake of this we'll just say x equal to minus 2. When you have a situation like this, now later on we will be talking about this a bit more, but so this is kind of for your own general knowledge, I guess, but when you have a situation like this where both of the brackets give you the same answer, you could say that the quadratic equation solution is x equal to minus 2 with multiplicity of 2, right? So this is the, actually I could just, I'm just going to type it out instead because it's better. This is multiplicity, alright? This is known as multiplicity. So this basically means that x equals to minus 2 appears twice in both of them here. So that's literally what it means. But this is kind of a more, I guess, formal way of saying that it appears twice. So it's just to say that, hey, there's still two solutions, but we're not actually going to say there's two solutions, But yeah, simply put though, x equal to minus 2. That's the solution for this quadratic equation. Okay, next one that is actually a bit simpler. Now, in this situation with x squared minus x equals to 2, okay, this is a bit weird because it's not in the form of equal to minus 0. So what do? Well, quite simply, we actually we have to make sure we have an equal to 0 on the right side. Remember that when you solve quadratic equations, you can only do it when you have equal to 0. Such that this method will work, such that you can get that valid method and you can get an answer. And it's the same, it will become valid for other methods as well, such as using the quadratic formula, completing the square, and such as we'll do in the future videos. But in this situation we have an equal to, so we need to move this, and quite simply we'll just move it to the other end. So x squared that looks more like a 1 than a 2, but you get the idea. X squared minus x, and remember we are moving the 2 over to the other end, so we're gonna subtract 2 from both sides. Now this looks more in line with a typical quadratic equation format. Now again, we just factorize this out. So two numbers that give you minus 1 and two numbers that give you minus 2. So in this situation, because I've already done it in my head, the answer in this situation would be equal to 1 and minus, sorry, it'll be minus 2, yeah, that's right, yeah, minus 2 and 1. So x equal to minus 2 and x plus 1. Again, if you wanna test that itself, you can just expand it out and you should get that. And again, another way to test it is minus 2 times 1 is minus 2 at the end, and minus 2 plus 1 is just minus 1. So it works. And now that is equal to 0. So again, we just follow the same kind of method, as we've done here. So I'm not going to do that. Again, we could just kind of jump straight. So we could say x is equal to 2 and minus 1. There we go. And yeah, that's it with that one. So you can see x is equal to 2 and minus 1 because we just flipped the signs over here with the both of them. And it's a result of doing this kind of method as we've done many times now. So final example is we're now going to be using the difference of two squares here. So you can see right away x squared minus 16 is equal to 0. We've already talked about this in the previous video. Talked about when to use difference of two squares is when both terms are square numbers and then there's a minus between them. So in this case, I've already mentioned this in the previous video, so go back if you're not familiar with this. but I'm going to jump straight to the factorized form because it's quite simply, you know, very easy to do. So in this situation, it's quite simply x minus 4 and x plus 4 is equal to 0. Okay, cool. Now again, we just, you know, use the same method as done here and here, or not here, so here, you know. So we're going to get x is equal to 4 and minus 4. There's another way to write this, by the way. If you want to make it more compact and easier to read, and you can say plus minus 4. And that simply means it's either plus 4 or it's minus 4. So it's the same thing as that, but it's just more put together. Now, another thing with this, you can solve this in a different way actually, using using standard linear equation techniques actually. So let's solve this a different way, real quick. Because this one, there's no middle term here, so you can actually do this. Let's move minus 16 over to the other side. So let's do x squared is equal to 16. And now you can see here, both sides are squared here. So you can actually just square root both sides, as we've done quite a while ago now. We kind of briefly touched over it with, rearranging, rearranging for the subject and such, you know, changing the subject. We've kind of touched on that with this kind of situation, but we can apply it here as well. So let's square root both sides, and we can see that we have x is equal to 4, if you square both sides. Now, key thing to remember here, as we will be using in the future with physics stuff and more maths, key thing to note is remember that 4 is not just the only solution here, because, you know, as we've seen with the left side here, because 4 squared does, 4 squared does give you 16, right? 4 times 4, 16. But it's not the only one that gives you 16. In fact, minus 4 also gives you 16, because minus 4 times minus 4 is 16. So if you square root both sides here, you have to remember to add the plus minus sign here, or you can just write it as 4 and minus 4. So this is a quicker way of doing it actually in this situation. But I wanted to use differences of 2 squares so you can get used to the factorization methods and such. So both methods are valid, they give you the same answer. You can choose either one, it really doesn't matter, because they're both valid. So whichever one is more comfortable for you, whichever one is easier, you know, things like that. Okay, so that is all I had to say on solving simple quadratic equations. That and also marks the end of the Tier 1 foundation things. This marks the end of the Tier 1 foundation videos. So we're now going to be bridging on, we're going to be moving on to the Tier 2 videos in the next video. We're going to be talking about the higher tier. So if you're a foundation tier student and you're not doing higher tier, you can pretty much stop here with the algebra, because this is pretty much all you need to know for GCSE algebra at foundation level. If you're a higher tier student, then I hope this served as a good refresher for a lot of top concepts you need, because we're going to be using a lot of these for the higher tier topics now. Okay, so thank you guys so much for watching, and I'll see you all in the next video.